Well, here we're going to look at 1999, question 1, part B. So it's a linear motion question with multiple different stages on it. So we have a bit of information: constant acceleration f for 2 seconds, travels at a further constant speed, and then slows down. So our first part of the question, part 1, is to draw the speed time graph for the motion. And even if this wasn't asked as a part 1, we should do it anyway, so we can see what we're going to do. Now, you got to be careful on this one here, because there's a little bit of a trap on it. So there is our, speed and time. Let's have a little look over the question before we dive in and start drawing this. Travel in a straight line with constant acceleration f for 2t seconds. It doesn't tell us if it starts at 0. And actually, if we read down through the question a bit to part 2, find the initial velocity of the particle, which implies it's not 0. So it is going to start up there. All right. Then it goes along, constant speed, and it is brought to a rest by constant retardation 3f. It's a bit of a steeper one. So there we go. Now, let's put a little bit of information on this one. So that is 3f there, and that's f. We don't know this. Okay, that's u, and this is going to be v. And we'll divide this into our different sections. There we go, just like light little lines, because we are given some time. So 2t seconds for the first one, so 2t. Now, just on a small little note, in many cases it's more useful to write the interval, so the next one's going to be 5t. So, you know, this point is, of course, 7t and so on. If I'm going to write it as an interval, I'll write it in the middle. If I'm going to write it at a point in time, I'll write it along there. Okay, so that point in time is 7t, but if I'm only interested in the interval, I'll write it in the middle. You can work with either, but this is fairly handy. And we'll need the last bit. Eventually, we're going to call that one T3, because this is kind of section 3 of the whole thing. Now, what do we know in this one? We know the total distance is S1 equals 15, S2 equals 55, and S3 is unknown. Okay, any other information? Let's have a little quick look over it. No. So this is part 1 done, our speed time graph. Now, part 2. Let's have a little look at this. The initial velocity in terms of t. So I want u. Okay, well, if we look at this bit here, now there's a few different ways to go with these questions. My personal favorite is area. Okay, and it just can be a little bit simpler overall sometimes. Sometimes the maths is a tiny bit longer, but less complex. So if we divide this into 2 sections, all right, we have S1 is 15 meters. So that equals this area here, which is 2t by u, and this area here plus, now area of a triangle, half the base by the height, so it is a half by 2t by that distance there, which is v minus u. Okay, looking a little bit messy, but not too bad. Let's see what we can figure out in this one, because some of this is going to come out. So 15 is 2tu plus, and that's just going to, they're going to cancel each other out, tv minus ut. Okay, so 15 equals vt, we'll just rearrange them so it's a little bit neater, plus ut. All right, that's not quite so bad. If I want to find u, so what I really need to do is find v now. So how can I find v? Well, let's look at the next bit of information we have. This big block here, and this is quite nice, S2, because S2, we know it's 55, and it's just a rectangle, so that equals 5t by v. All right, v being the height from there to there. So you can see this is going to come out nice and easily. So 11 equals tv, v equals 11 over t. Now, a small little word of warning here. Some of you like to write your t's like 4s, okay? Just do be careful. I know it's an annoying combination of letters and numbers, but make sure that does not look like a 4, or things will begin to go wrong. So, sub in v. So we have 15 equals 11 over t by t. You can see where this is going, plus ut. So 15 equals 11 plus ut. We have a little bit of space left here. So ut equals 4. Just come across here. Therefore, t equals, oops, of course we could find t, but we don't want t, we want u. Therefore, u equals 4 over t. And this is a bit the 4's and t's, mind that one there. So that is our initial speed in terms of t. There we have it. Okay, now part 3. We'll come up here for part 3. We have both our accelerations, so we could do this in terms of the angles in here and here. But like I said, I'm going to go with area for this one. Just it's another way to go. You might have your own personal preferences. Sometimes if you're getting a bit confused in the tans and so on, the trigonometry can be messier. This is more straightforward mathematically, even if it's not quite so elegant. So we want the total distance traveled. Well, total distance equals 15 plus 55 plus S3. Now, I like to write this up because the temptation it is, you got to go and find S3 and you go, boom, there's my answer, and forget that we're looking for total distance and lose silly marks. Okay, correct 2 decimal places is going to be messy. So how are we going to look at this? Well, I would like to look at this triangle. So I know that S3 equals a half by V by T3. Okay, I'm just calling it T3 because this is section 3 of the whole thing. So S3 equals, we do know V, let's pop that in there. So we have a half 11 over T, T3. Okay, just a little bit tidying up 2T by T3. All right, we're getting there. So if I could find the time, then I've got this. Well, what else do we know about this one? So it's a nice little triangle. We know it's going to slow down. So let's look at V equals U plus AT. Because I know it's going to go to 0. So 0, so the initial velocity. It's going to be, just kind of be careful in your things. I put them in boxes if I'm just looking at an equation. The initial velocity at the start of this section is V. And I'm going to write it in as 11 over T, so I'm not going to get confused. Plus minus 3F and T3. So let's see what we can do in this one. Bring these guys over here. 3F T3 equals 11 over T. We're getting there. We're getting there. I've still got 2 unknowns, T3 and F. So let's see, can we solve the F? Okay, find F. Well, where else do I have F? I have F back here. All right. I now know U, and a little bit of a tip on this one. Sometimes it can be no harm to write these guys in. So U was 4 over T, and V is 11 over T. Good idea to do it as you go, just so you can see all your information. Because now actually finding F over here may be possible. So section 1, V equals U plus AT. Well, V is 11 over T equals 4 over T plus F by 2T. Okay, now I'm going to find F in terms of T. So again, a little bit of tidying up. I'm going to multiply everything by T. 11 equals 4 plus 2ft squared. 2ft squared equals 7. T squared equals 7 over 2f. But of course, that's not what I want. So we'll just ignore that because I want it in terms of f. F equals 7 over 2t squared. Okay, so now we're getting a little bit closer. I think we'll make a little extra column here. I'll squeeze it in the end of this page. I now have f, which can give me T3, which can give me this. So let's just call this equation sections 1, 2, and 3. So we'll call this guy equation 4. I'll call this guy equation 5. So subbing 5 into 4, we get, remember I'm looking for T3, so we get 3 times 7 over 2t squared t3 equals 11 over t. Okay, a little bit messy. We'll lose our t's. We'll multiply that in. 21 over 2 t by t3 equals 11. t3 equals 22t over 21. Okay, so now I have t3, and we'll put this one in to here. So sub t3 into this equation. So now what I have is S3 equals 11 over 2t, factor of 22t over 21, and this is going to tidy up a whole lot more. And that is going to divide both sides by 2t, 121 over 21. Now, so then my total distance equals 15 plus 55 plus 121 over 21. And we grab our calculator and we'll be all sorted. Two decimal places, we will go equals 75.76 meters. And there we go. So like I said, you can do this definitely in less lines with the tans if you prefer, but algebraically or mathematically this can be a little bit more straightforward because we're just trying to find an area and we're working through our different equations to work out our variables. So it's good practice for working through your variables anyway.